Alrighty, one more video, I believe, for section 4.4, examples 4 and 5. We're just solving all these equations. We're using these substitutions from identities we learned in chapter 3 so that we can get one, either get it down to one trig function or sometimes get it down to one particular angle, right? So let's see what we can do with this one. This one's our double angle for sine. So we're going to replace that with 2 sine x cosine x. Ooh, I already see a concern, and that is we still are going to have both a sine and a cosine. Don't worry, it's going to work out. Let's get everything on one side again. So 2 sine x cosine x, subtract the other stuff to the other side, negative square root of 3 cosine x, all that equals 0. So we don't have like cosine squared here like we've had in other problems where we can factor quadratic, but instead notice how we have this cosine in both of these terms. That means we can factor out that cosine from each term and then just be left with 2 sine x minus the square root of 3. Isn't that nice? Because even though this isn't a quadratic, we can still use the zero product property. We can still take each factor, set it equal to 0, and solve it. So this one, cosine x equals 0. Cosine is 0 at pi halves and at 3 pi halves. Of course, if we were doing more than just 0 to 2 pi, we could keep going. 5 pi halves, you know, we could add our pi k to that and use all the infinite values of k to find all the infinite answers. But these are the only two that'll be from 0 to 2 pi. Okay, then we're just going to take this factor, 2 sine x minus square root of 3 equals 0, which means 2 sine x equals square root of 3, which means sine x equals square root of 3 divided by 2. So that's a positive ratio. That would mean we have answers in quadrant 1 and quadrant 2. Square root of 3 over 2 is a pi thirds reference angle, right? So quadrant 1 would be pi thirds, and quadrant 2 would be 2 pi thirds. And then, of course, if we wanted infinite answers, we would add 2 pi k to each of those to find our infinite answers. But there's no need to, because that's as far as we're going to be able to go. If we go further into quadrant 3 or 4, those are negative square root of 3 over 2, not positive. So we're done. So our solutions from 0 to 2 pi are pi halves, 3 pi halves, pi thirds, and 2 pi thirds. All right, next. Example number 5. This one's a weird one. Have to be able to recognize identities. So memorizing these just helps you to be able to keep using those proteins. So do we recognize this? This is an identity. This is the sum identity for sine. We have sum and difference identities. This is our sum identity for sine. And basically what it's saying is sine alpha cosine beta plus cosine alpha sine beta. So that would mean x is alpha and x over 2 is beta. So we could rewrite that whole thing as sine of x plus x over 2 equals 1, which simply means 3x over 2 equals 1, which means the inverse sine of 1 equals 3x over 2, and the inverse sine of 1 only is at pi halves. That's the only answer from 0 to 2 pi. I mean, if we wanted to be really careful, we could say, okay, well, it's pi halves, and then that could repeat all the way around. We're not going to have a 3 pi halves because that would be a negative 1. So pi halves is the only place that sine is a negative 1. I mean, a positive 1, sorry. So pi halves plus 2 pi to get to the next one, which would be 5 pi halves, and then plus 2 pi to get to the next one. But obviously, we're beyond where we need our answers to be. However, this has some funky stuff in it. So we might actually need that information to help us find all the answers. So we probably should write it down regardless, just to make sure. This is why I've been writing it down on every problem, because you can't just assume you don't need it just because we haven't been needing it, because at some point we might need it. Okay, so hopefully this inverse sine of 1 turning into this answer makes sense. We've been doing that in every problem, and then it's equal to this because that's what the argument was in the angle before we used the inverse. Okay, so this we already talked about is going to be the only possibility because that's the only place the sine equals 1. Okay, let's go ahead and solve this. So I'm going to go ahead and get rid of the 2's by multiplying everything by 2. So that would give us pi plus 4 pi k equals 3x. I'm trying to solve for x, correct? So then dividing everything by 3, we would have pi thirds plus 4 pi thirds k. So that will represent our answers. So if k equals 1, let's start with k equals 0. So if k equals 0, then x equals pi thirds plus 0, which is pi thirds, right? If k equals 1, then we add 4 pi thirds to our pi thirds, because we multiply by 1. Add it in, we get 5 pi thirds. That takes us clear into quadrant 4. I don't think we need to do k equals 2, because that's going to take us beyond 2 pi. I mean, we could actually try it, make sure, but I'm not going to worry about it. Those are the only answers we will get from 0 to 2 pi for this particular question.